is this apple matter? Well, it takes up some space and it has some weight, but what about this salt? Is this salt matter? Well, it takes up less space and it has less mass, but it still takes up space and has mass. What about air? Is air matter? Let's use this balloon to find out. Yeah, air takes up space. So anything that takes up space or has mass is matter. And pretty much everything in the universe is made of matter. So that's our first vocab word. Remember, your notebook should be out. You can pause if you need to. And when we take up space, that really is volume in science, and weight is really mass. Everything in the universe is made of matter, and it just depends on what matter is inside of it that makes everything look so different. So, for example, this apple is made up of carbon and oxygen and hydrogen. And if we switch the elements around, we might get something that looks or tastes or feels different. For example, this salt is made up of the element sodium and also chloride. And the balloon, the rubber that we had, is also carbon, like the apple, but it has more hydrogen and no oxygen. So depending on which elements are inside of matter, it's going to look, taste, feel, smell different. An element is just a pure substance that makes up matter. That's our next vocab word. But to find out why the apple looks different than the salt and even than the rubber, we actually have to take a deeper look inside of our element. Behind me, we see all of these elements, but the main thing that's important about our elements is the number of protons. First, let's make sure we write down what an atom is. If we dive deep into an element and we take a tiny part of it, that's called an atom. And I already told you that the most important part of an atom is the number of protons. For example, carbon has 6 protons, and if it had any more, it would change to nitrogen. And if it had any less, it would change to boron. So the proton is larger than charge, it's positive, and it's in charge of which element the atom's going to be. The next part of our element that's also inside of our nucleus is the neutron. Our neutron has no charge, it's neutral. It's also large and it's inside the nucleus. So we have protons that are positive inside, and we have neutrons that are neutral, no charge. Those are also inside. But why things react, that has to do with the electrons. If you think about electrons, it sounds a lot like the word electricity. And that's the reason, where's my plug? And that's the reason when we think about electricity, we're also actually thinking about electrons moving. Because electrons are really teeny tiny, those things can fly around the nucleus whenever they want, and they take up the most space within an atom. So electrons are tiny, they're negatively charged, that's why you zap someone if you electrocute them. And we know that they fly around the nucleus. So let's write that down. And the last thing we want to do is make sure we draw an atomic model. So remember, protons, neutrons, big, inside. Protons, positive. Electrons, teeny tiny, negative. and those are going to float around outside. Atomic model. We have our nucleus. I have 3 positively charged protons. I have 3 neutrons, which I left blank, and then flying around, these tiny things right here are our electrons. 1, 2, and 3. So, again, all things in the universe are made of matter if they take up volume and if they have mass. The reason that all matter looks different is because they're made of different elements. Each element is a pure substance, and each tiny part of that substance is an atom. We have protons, neutrons, and electrons. Protons are positive, electrons teeny tiny and negative, and they fly around and they're able to move, which helps us with chemical reactions.